Assalamualaikum everyone. So it's a second lesson of our chapter number 15. So what we will discuss there, electrolysis of aqueous solution. So what is aqueous solution actually? Aqueous solution is a mixture of compound and water. When we add any compound in the water and stir it, then what happened? Aqueous solution is formed. So electrolysis of an aqueous solution is more complex. Why? Why electrolysis of aqueous solution is more complex? Due to the presence of two or more electrode and ions in it. So here is the mixture of sodium chloride and water. What happened there actually? There are four ions present in this electrolyte, two cations, two anions. So before this, we just discussed two ions which is present in our solution. One is cation, one is anion. But in aqueous solution, there are four ions in one electrolyte. That's why electrolysis of aqueous solution is more complex. So here is a reactivity series which helps us during electrolysis of aqueous solution. If inert electrodes are used during electrolysis, the ion discharge and product form are depend on selective discharge of cations, selective discharge of anions, and effect of concentration on selective discharge of anions. What is selective discharge of cations? So here is a reactivity series which give us an idea that which cation can go to the cathode and deposit it. So if there are two cations which is present in a solution, which will go to the cathode? So it's a difficulty if there is two cations. Can both cations go to the anode and gain the electron, or only one can go? So it's quite difficult. That's why we have this reactivity series to judge which cation go to the cathode and gain an electron. So here is an example. If sodium and hydrogen ion is present in a solution, then what happened? So where is the sodium? So this is the sodium, and here is the hydrogen ion. So we know increasing ease of discharge from there. It means hydrogen is preferable according to this reactivity series. So if hydrogen ion and sodium ion is present in a solution, which is preferable? Yes, hydrogen ion is hydrogen ion is preferable in that condition. Okay, if hydrogen and copper present in a solution, then which will be preferable? Which is present below in this series. So copper is present below this hydrogen. It means copper ion is preferable if hydrogen and copper is present in the same solution. As it is, there is some rules for predicting selective discharge of anions. Here are some anions. Okay, there is an increased ease of discharge. If we have a solution in which chloride and OH negative ion is present, then what happens? Which will go to the anode and give the electron. Okay, so which is present below in this reactivity series? Yes, OH negative is preferable in this condition if a solution have Cl negative and OH negative in the same solution. If both NO3 and OH ions are present, then which will preferable? Yes, which is present below this series. So OH negative is present below. That's why OH negative is preferable there. So OH negative go to the anode and lose its electron. General rules for predicting the products and electrolysis. First of all, we should to identify the cations and anions. We should to know which cation and anion is present in an electrolyte. Then determine the anion which will go to the anode. Yes, that is discharged at the anode and lose its electron. So determine the cation. The very first step we should to identify the cations and anions, and the second we determine which anion can go to the anode, and then we can determine which cation go to the cathode and discharge according to the reactivity series. At the end, we can identify cation and anion which is remain present in our solution, and which is at the end which cation and anion is present combine together and form our product. So there is a rule. If we can use concentrated solution, concentrated means our compound have more amount as compared to water, where more amount of something is present. So in our preference or according to our reactivity series, the ions which is present more can go to the anode and cathode rather than reactivity series. So let me check what happened in the solution of sodium chloride, which is dilute. Dilute means a very small amount of sodium chloride is present in this solution. So here is our electrolytic cell where is sodium and chloride ion is present in this solution. H and OH negative ion is present in this solution. So there are four ions: sodium ion, hydrogen ion, chlorine ion, and hydroxide ion. So then we will discuss what happened. The very first rule is identify which anion and cation is present in our electrolyte. So we identify if the dilute solution of sodium chloride is, so sodium and chloride, hydrogen and hydroxide ion is present in this solution. What happened at anode? It's our second rule in which we can check what happened at the anode. So as we know, there are two anions, OH negative and Cl negative is present there. But now we use what? Preferable reactivity series. So in our preferable reactivity series, OH negative ion is preferable because it can lies in this series below the chloride ion. So what happened? OH negative ion comes to the anode and release the electron, lose its electrons and become water and oxygen gas. Water can go back to the solution and become more diluted, and oxygen in the form of gas evolve out. So chloride ion remains in the solution. Okay. So what happened? Hydroxide ion goes to the anode, become the hydrogen gas and evolve out. But chloride ions remains in this solution. Now, rule number 3. What happened at the cathode? So, we know that there are two cations, H positive and sodium positive ion. So, in this both, we know that which is present below in our reactivity series. Yes, hydrogen ion is present below in reactivity series, so it is preferable that hydrogen goes to the cathode and gain the electron. So what happened? The electrons comes to the anode and move to the cathode, like positive to the negative terminal. So H positive ions come and gain the electron and become hydrogen gas. So hydrogen in the form of gas evolve out. So what's the remains in the solution? Sodium. So what is our overall reaction actually? At anode, Cl negative ions are present. At cathode, sodium ions is present in our solution. So water, when water is electrolyzed, hydrogen and oxygen gas evolves out. But at the end, what we have? The concentration of sodium chloride molecule is more as compared to water. So as water is removed in the form of hydrogen and oxygen gas, the concentration of sodium chloride solution gradually increases. As electrolysis going on, oxygen and hydrogen gas evolves out, chloride and sodium ions can remain in this solution. At the end, sodium and chloride ions combine together and the concentration of sodium chloride in the solution increases. Okay, let's take another example in which we can electrolyze the concentrated sodium chloride solution. So concentrated means we can add a lot of amount of sodium chloride in water and form a aqueous solution. So in this aqueous solution, let's find what happened in electrons. The very first rule number one, we have to judge which cation and anion is present in this solution. So concentrated means sodium and chloride ion present in large number of ion, and hydrogen and hydroxide ion is in least amount. So what happened at anode? So here is a rule from a reactivity series that the thing which is present in more amount is go to the anode, and then what is happened? Yes, so chlorine can go to the anode and leave, lose its electrons. Okay, there are two anions, OH negative and Cl negative ions present in this electrolyte. When electricity passed through it, battery is joined, then what happened? Chloride ions, because it is present in more amount, can go to the anode and lose its electrons. So OH negative ions remains in the solution. So rule number three, at the cathode, hydrogen and sodium ions are attracted to the carbon. Inert cathode. Sodium is higher in reactive series. So sodium ions are not discharged. So here hydrogen is preferably go to the cathode because hydrogen is present below to the sodium. So go to the cathode and gain the electrons. After gaining electrons, it becomes hydrogen gas and evolve out from the solution. But at anode, chlorine gas can evolve out from the solution. So what else remains in our solution actually? At cathode, sodium ions remains in the solution. At anode, OH negative ions remains in the solution. So, rule number four, let me summarize what happened in our electrolysis of this concentrated sodium chloride solution. One volume of hydrogen gas is given off at the cathode and one volume of chlorine gas is produced at the anode. What is the remaining? Sodium and hydroxide ions. So both have the oppositely charged ions. Both can attract to each other and form a new compound which is sodium hydroxide. So the resulting solution becomes alkaline because chlorine and hydrogen gas is evolved out and remaining as sodium hydroxide remains present in our solution. So here is the question which comes in our mind, which is that if sodium sodium chloride is in concentrated form and have a large amount in this solution, then why here chlorine, chlorine, chloride ion goes there, and here why sodium not goes there? Because according to our reactivity series, only N9s. N9s is preferable in concentrated form. So that's why chloride ion is an anion. That's why we can use the third law of our reactivity series, which is that if anion is in concentrated form is in large amount, then we will preferable this ion which is present in the large amount. But in the cation, there is no specific rule. That's why we can use for cations only the reactivity series where hydrogen is present below. That's why we use hydrogen in the cation, but at the anode, chloride ion is preferable. Here is another example, which is copper sulfate solution. What happened when we form a copper sulfate solution? First of all, the solution contains four ions. Which ions? Copper, 2 positive, sulfate, 2 negative, and water ions, H positive and OH negative. So the rule number first, identify the cations and anions. You identified it, copper sulfate and hydrogen and hydroxide ions. Now the rule number two, at the anode. What happened at the anode actually? So at the anode, two anions are present. When we pass the electricity, two anions goes to the anode, but which will deposit there. So SO4 two positive ions are not discharged instead of OH negative ions, because OH negative ion is preferable according to the reactivity series. So OH negative ion goes to the anode and lose its electrons. When OH negative ions goes to the anode, it will form the water molecule and oxygen gas and also lose electrons. So oxygen gas can revolve out from this solution and electrons can move from positive terminal to the negative terminal of the battery and goes to the cathode. Then what? What is remains in our solution? SO4 2 negative is remains in our solution. At the cathode, there are two ions, hydrogen ion and copper 2 positive ions. So what happened? Which will be preferable there? Copper. So copper is present in our preferable reactivity series below hydrogen. So you know that below have a ease of increase of discharge. So copper can go to the cathode and will discharge there. What will happen? Copper can gain the electrons and in the solid form it will remain in the solid form, copper deposited in the solution. So hydrogen ions remains in the solution. So rule number 4, we have to summarize the reaction, what happened at cathode and anode. So SO4 2 negative is present in the solution and H positive is present in the solution. But oxygen gas is evolved out and copper is present in the solid form. So what happened at the end? Yes, H positive and SO4 2 negative both have the oppositely charged ions, both attract together and form a new compound which is sulfuric acid. It means after electrolysis, the product which we obtain is sulfuric acid. So, here is the last topic of this chapter, which is electrolysis of water. Electrolysis of Pure water. Here is a term that pure water is a poor conductor of electricity. So, to conduct the electricity, we add some amount of salt in the pure water. Then what happens? When we add a pinch of salt in the water and make a solution, then we can conduct electrolysis there. Then what happens? So, hydrogen can broke down into two ions, H positive and OH negative. Then what happens? H positive ions can go to the cathode and OH negative ion can go to the anode. OH negative ion can go to the anode, give it lose its electrons and in the form of oxygen evolve out. And hydrogen can go to the cathode and gain the electron and in the form of gas can evolve out. At the end of this reaction, we judge there is a double amount of hydrogen gas as compared to oxygen gas. Why? Because we know that hydrogen in the formula of hydrogen, two hydrogen atoms can combine with one oxygen and form a molecule of water. That's why after electrolysis we can obtain double amount of hydrogen gas as compared to oxygen gas. So we will meet in our next lesson with a new topic which is industrial application of electrolysis. So take care of yourself.